Let's sit outside. I see a table there at the edge of the patio, where there is no guardrail to block our view.
Look at all the birds. So many of them, all clumped together.
It is so nice out here, but it is very crowded. I do not think a waiter will come very soon, to ask what we want to eat.
That doesn't bother me. I'm happy to just sit here and shoot the breeze. While we are waiting, I have a question for you. Is there a difference between Bayes' theorem and the definition of conditional probability? Or is this yet another example of only a single idea that has several different names?
I think I asked myself that question once. And I was able to figure out a good answer. But I forgot what it is.
I see you have your phone with you, and the reception here is good. If we look up the definitions of the two concepts, I think we can figure it out again.
Okay, so I will do a Google search, and maybe look in Wikipedia, and also on Stack Overflow, Quora, and YouTube. Look here, I found something. I see here that the conditional probability of an event occurring, subject to the constraint that one of its possible causes is known to have occurred, is merely the probability of both occurring, divided by the probability that the potential cause will occur. In contrast, Bayes' theorem seems to be focused on describing one conditional probability, in terms of other conditional probabilities.
Yes, it looks like although it is easy to prove Bayes' theorem by using the definition of conditional probability, Bayes' theorem tells us something slightly more specific. For example, it tells us how to compute the probability of an experimental outcome, subject to the constraint that one of its possible causes has occurred, in terms of the opposite.
Yes, like for example the probability that people who run red lights will get into car accidents, in terms of the probability that people who have been in car accidents have run red lights.
Does it even make sense to talk about the probability that you failed to respect a red traffic light, subject to the constraint that you have been in an accident? In other words, does it make sense to talk about the probability of an event that happened in the past, or to talk about the probability that a particular cause was responsible for an event?
That is one of my favorite questions. I think the answer depends on whether or not you are willing to use the mathematics of probability to quantify ignorance.
It is certainly possible for a historian to be uncertain about the past.
Yes, but it is useful to notice that quantification of a historian's uncertainty about an event is not a description of the event, but a description of the historian.
Is bad taste a property of food, or a property of the mind of someone who is eating that food? If everybody agrees that something tastes bad, it is not unusual to simplify discussion and say the food tastes bad, even if bad taste is actually a property of an entire system, which includes food and people.
I think what you just said might be useful for understanding the root cause of many disagreements about what probabilities are. A few years ago, I was surprised to read that even now in the 21st century, there exists quite a bit of unresolved controversy pertaining to probability among scientists, mathematicians, and philosophers.
Are you saying that the mathematics of probability has not yet been fully worked out? Are people still having debates about whether or not basic theorems are true?
No, they all agree on the math, but not on the circumstances in which it is acceptable to use that math, and on what the results mean.
They cannot agree on whether the probability of an experimental outcome is a description of the propensity of an experimental apparatus to produce that outcome, or a description of the uncertainty in the mind of an experimenter about what that outcome will be.
But is there a difference between those two things? If the experiment is to flip a coin, the first idea describes how often the coin lands heads up, and the second idea describes how often a gambler can guess the outcome. I think the two numbers will be the same thing.
I suspect the two quantities in the specific example you presented are equal to each other if the gambler is maximally well informed about the geometry of the coin, and the coin is being flipped by a typically unskilled human being. However, one could argue that in general, the two concepts are not the same.
How are they different from each other?
As more information is gained by a gambler who is a mere bystander and has no control over the experiment, we would expect that gambler's rate of success in predicting the outcome of the experiment to change. But we would not expect that gambler's knowledge to have any impact on the propensity of the experimental apparatus to produce any particular outcome. The physicist Edwin James described that idea in a book called Probability, The Logic of Science.
I have heard of this Edwin James. He is a big fan of what is called the Bayesian interpretation of probability. For many years, his book was available for free, in electronic form, on his Washington University of St. Louis website.
Yes, but I should say that having read his book with great care, I have come to the conclusion that his point of view is far more precise and interesting than what is often described as the Bayesian viewpoint.
Could you remind me, what exactly the Bayesian viewpoint is?
More or less, it is merely one of the two viewpoints we have just described. The so-called Bayesian interpretation of the mathematics of probability is often contrasted with the so-called frequentist viewpoint as follows. Bayesians regard the probability of an experimental outcome as a quantification of the degree to which it is reasonable to believe that the outcome will occur. This is consistent with the viewpoint proposed by the physicist James Clerk Maxwell as the degree of belief that is, or at least ought to be, in a rational man's mind. In contrast, frequentists regard the probability of an experimental outcome as the fraction of times that outcome occurs if the experiment is performed many times. The latter sounds a lot more objective, but seems far less widely applicable. The philosopher of science Donald Gillis describes these supposedly incompatible viewpoints in great detail in a wonderful book called Philosophical Theories of Probability.
You said supposedly incompatible. Does that mean you do not believe the viewpoints are actually incompatible?
That is correct. I do not believe the most interesting and useful aspects of the Bayesian and frequentist viewpoints are incompatible with each other, but that many descriptions of those viewpoints are slightly flawed. Edwin James flat out says that frequentists have repeatedly mischaracterized the Bayesian viewpoint, and I don't doubt that the reverse has also occurred.
I think that frequency of occurrence would be a good way to objectively quantify the degree of belief that, as James Clerk Maxwell said, ought to be in a rational man's mind. What is there for Bayesians and frequentists to disagree about?
In order to be able to measure a frequency of occurrence, you have to be able to repeat an experiment many times. Frequentists claim that it makes no sense to talk about the probability of an experimental outcome if the experiment cannot be repeated.
I see. So according to the frequentists, it makes no sense to talk about the probability that a particular candidate will win a particular election, or the probability that it will rain tomorrow. No two elections are exactly the same.
So frequentists think it makes no sense to talk about the probability that an unrepeatable experiment will produce a particular outcome. They are happy when I use the mathematics of probability to describe my chances of winning at gambling in Las Vegas. But they think I am crazy if I use probability to describe the gambles I make each day, when I decide how likely it is that I will be run over by a bus if I attempt to cross the street.
Do you think it makes sense to attempt to quantify uncertainty regarding what the outcome of an unrepeatable experiment will be? For example, is the probability that a specific 40-year-old man will die before he turns 41 a well-defined quantity?
Donald Gillis discusses an example of this sort in great detail.
I'm not sure what to think. My neighbor is 40, and his insurance company is interested in how likely it is that he will die before turning 41. But it seems like the number they come up with to describe the likelihood of his death depends on how much they know about him and his environment. For example, they could come up with one number based on the knowledge that he is not an underwater welder, but an accountant. But would probably want to revise that number if they found out that he smokes 3 packs of cigarettes a day. And revise it again if they found out that all his relatives were heavy smokers, and that none died of cancer. If the insurance company knew everything about him and his environment, including the trajectories of all meteorites that might fall from the sky and kill him, there would be no uncertainty to quantify. They would be able to correctly predict the exact time and cost of his death.
You have just described what is called the reference class problem. One could argue that it is because of this problem that the Bayesian viewpoint is often regarded as being subjective, and also that it is because of this problem that the Bayesian viewpoint is regarded as epistemological. In other words, regarded as a viewpoint according to which probability is mere quantification of the magnitude of my knowledge of a phenomenon, rather than a description of the phenomenon itself. According to the Bayesian viewpoint, two different forecasters who are not equally well informed are expected to assign very different probabilities to the exact same event. However, this does not, in my opinion, make the Bayesian viewpoint subjective. Edwin James pointed out that two forecasters who are equally well informed must assign the same probability to the same event if it is their goal to be rational and consistent. It is my opinion that there exists an objective way to choose a reference class whenever one is attempting to quantify the ignorance of any particular forecaster, and that this reference class is the set of all experiments that could have produced the data the forecaster observed, and that to the forecaster are indistinguishable from each other.
I see. So when the weatherman tells me that the chance of rain tomorrow is 80%, I should interpret this as meaning that in the equivalence class of meteorological conditions, which he cannot distinguish from those that exist today, there has been rain on the subsequent day in 80% of cases. It is only because there exist cases which to him are indistinguishable, but which do not yield the same outcome, that he is uncertain about his forecast. The idea you described, that it is always possible to objectively quantify how much knowledge a forecaster has, seems defensible to me. As does the idea that a frequency of occurrence in a reference class of experiments that are indistinguishable to the forecaster is a good way to do it. But I am not ready to believe that each probability can only be interpreted as a quantification of how much knowledge a forecaster has. To me, it seems, whether or not each probability can only be interpreted in such a way, depends on whether or not the universe is deterministic. And whether or not that is the case, is not a question for mathematicians or philosophers. It is an experimental question for physicists. If the universe is deterministic. In other words, if all experiments have the property that they always produce the same outcome whenever they are repeated in exactly the same way, then clearly, each probability is just a quantification of how much knowledge a forecaster has. But what if some phenomena, for example pertaining to radioactive decay of atoms, are truly non-deterministic, and can be used to construct experiments that do not produce the same outcome, even when they are repeated in the exact same way? Then there exists a well-defined narrowest reference class, from which uncertainty can never disappear, and in which all forecasters perceive the same frequency of occurrence. No matter how well informed they become, they cannot make the reference class more narrow. I am talking about the reference class, comprised of only one specific non-deterministic experiment, which, because it is by definition non-deterministic, can be counted on to not produce the same outcome each time it is repeated.
Even if, unlike the flip of a coin, it is repeated in the exact same way, so that differences between repetitions cannot be detected.
Even when viewing the experiment at the subatomic scale, while measuring time in nanoseconds, and distances in angstroms. Okay, that is a legitimate objection. Perhaps there exist situations, namely those that involve non-deterministic phenomena, if in fact such phenomena actually exist, in which probabilities represent propensities. On the other hand, probabilities clearly represent mere quantification of knowledge, when they are used to describe deterministic phenomena, if in fact truly deterministic phenomena actually exist. As Natasha pointed out, whether or not any particular phenomenon is deterministic or non-deterministic is an experimental question for physicists, not a metaphysical question for philosophers. What should we conclude from all of this?
How about concluding that just as addition and subtraction can be used both for accounting and mechanical engineering, just as the number 20 can equally well represent both the length of a boat in feet and the cost of a meal in dollars, so too, the mathematics of probability can be used for many things. It can be used both to objectively quantify the ignorance of forecasters regarding the past, present or future states of deterministic phenomena, and also to describe the propensities of non-deterministic experiments. To say that all probabilities represent propensities would be like saying that all numbers represent lengths. It seems unreasonable to state with certainty that today we know all possible uses that future generations will find for any particular mathematical concept.
That sounds good to me. It is yet another way to resolve Humphreys Paradox.
What is Humphreys Paradox?
It is the observation that if we insist on interpreting all probabilities as propensities, then situations arise in which we are forced to interpret the probability that a person died of a gunshot wound as the propensity of a corpse to have had its head perforated by a bullet. Donald Gillis suggests an interesting resolution to Humphreys' paradox, but I like this one as well. Like numbers, vectors, matrices and transformations, probabilities are just mathematical abstractions that have many uses. Probabilities can be used for quantifying uncertainty, and to satisfy rationality and consistency goals, they must comply with what are called Kolmodorov's axioms. However, we can stop short of describing the nature and cause of that uncertainty, just as, when we agree that numbers can describe one-dimensional magnitudes, we do not demand to know whether those magnitudes represent weights, lengths, volumes, costs, or any one of thousands of other possibilities.
Yes, and the formulation of those axioms you described, the specific choice of how to define those axioms, is well motivated, both by what is called the Ramsey-Definity theorem, and by the area of mathematics called measure theory.
So we could summarize our understanding by saying that probabilities are just Kolmogorov axiom-compliant quantifications of uncertainty. They are useful both for objectively quantifying the magnitude of the uncertainty that exists in the mind of a gambler regarding the past, present, or future state of an entity, regardless of whether or not that entity is deterministic, and they are also useful for describing the propensities of non-deterministic systems, without any reference to who is, or who is not, perceiving those systems.
Just as numbers are useful, both for describing my weight in kilograms, and the price of my dinner in dollars. I am interested in how to apply what we have discussed, to the flipping of coins. If a biased coin is flipped many times, at first a gambler may think that the frequency of heads-up landings will converge to 50%. But if that gambler watches many such coin flips, eventually he will learn that the coin is biased, and that the actual frequency of occurrence of heads-up landings is, for example, 30%. My question is this. Is the 30% a description of a propensity, or is it just an epistemological quantification of the gambler's knowledge, or is it both?
To me, it sure seems like a really good objective quantification of a gambler's knowledge. Regarding whether or not it can also be interpreted as a unique, well-defined propensity, I think the truth is that in the year 2015, the human species does not have enough knowledge to answer that seemingly simple question. We have reason to believe that if we impart the exact same initial conditions to a coin when we flip it, including angular velocity, momentum and so on, that it will land exactly the same way each time, unless some sort of earthquake or stray bullet interferes. So the 30% heads-up landings are caused not only by the geometry of the coin, but also by the human, who imparts initial conditions to the coin when flipping it. In the year 2015, we do not know for a fact that human beings are deterministic. The physicist Roger Penrose suggested that perhaps human neurons are amplifiers of quantum mechanical phenomena, not unlike photomultiplier tubes, and in the year 2015, the honest truth is that we do not know whether the subatomic world of quantum physics is deterministic, and we certainly don't know exactly what is happening inside of human brains, or how to build a human brain from scratch by assembling atoms one at a time. Furthermore, the author Kurt Vonnegut wrote that today most scientists believe human brains are computers made of meat, and then he asked, but what if they are radios? If the latter is in fact true, and for all we know it could be, then a detailed understanding of the human brain would be insufficient for understanding human capabilities, just as a detailed understanding of a telephone handset is insufficient for me to explain the linguistic capabilities of a person to whom I am talking on the phone.
This Kurt Vonnegut wisecrack might begin to seem more plausible and worthy of exploration. If despite our best efforts to harness all sorts of techniques, including quantum computing, and the mathematics of nonlinear dynamical systems that can be used to represent an infinite amount of information like the Mandelbrot set using finitely many rules, we find 200 years from now that we still have been unable to produce a computer that has human equivalent intelligence, and that occupies less space than an office building.
It is irrational to not accept our ignorance, and to pretend that we are more certain of our knowledge than is warranted by the evidence that is available to us.
When he said, I think therefore I am, the philosopher René Descartes was explaining that we can never know anything for sure, except that we exist. This does not mean that science is useless, but it does mean that maybe all probabilities are conditional, and that I cannot be sure that anything I read is true. I can only have an opinion about how likely it is to be true subject to the constraint that the world actually exists, in the form in which I think it exists. And that everything that I remember about the past really did happen, and is not just my hallucination. From what you said, it is my conclusion that if an experiment is actually non-deterministic, then its propensity to produce an outcome is the same as an objective quantification, if the ignorance of a maximally well-informed gambler about what that outcome will be.
I suspect it is also true that attempts to objectively quantify the ignorance of gamblers, and attempts to estimate propensities, often produce results that are good approximations to each other. So I do not need to know whether or not a phenomenon is non-deterministic, in order to figure out how to use the mathematics of probability to make useful forecasts.
There are more things about probability that I am curious about, but I see the waiter is coming to our table, so I will save my remaining questions for later. You should write down our conversation, and make a short movie from it. You can post the entire thing in the comedy section of YouTube, so that others can laugh at us.
Yes, and I can write, edit, and listen to performances of the entire screenplay, not in my office, but while walking on the beach, using my liquid speech app, running on my old iPhone 4S mobile telephone, that is still equipped with the iOS version 7.1 operating system.